Alright, in this short video, we're going to investigate some of the basic maths concepts that you might have studied in grade 6 or 7. First of all, what are integers? This is a term that shows up quite often in GRE maths. Integers are numbers that go up like this: 0, 1, 2, 3, 4. So these are integers, and so are their negative counterparts: a -1, -2, -3, -4. So all of these are integers. 1.5 is not an integer. Square root is not an integer. So any number that has decimal places is not an integer. These numbers, 1, 2, 3, 4, 5, these are all positive. So these are known as positive integers. And these are known as negative integers. Negative. 0 is just an integer. It's not positive, it's not negative. Next term we're going to investigate is factors. Factors or divisors. Factors and divisors are simply numbers that can divide another number. So for example, what are factors of 24? Factors of 24 are numbers that can divide 24. Actually 1 can divide any number. 2, 3, 4, 6, 12, and including itself. So 1, 2, 3, 4, 6, 12, 24. These are all factors of 24 simply because 24 can be divided by all of these numbers, and these are sometimes called divisors. There's another term that you must understand, and that is quotient. So if you divide 24 by, let's say 3, you divide 24 by 3, then what you get over here, you see 3 times 8 is 24. And in this case, 8 is called the quotient. If 24 is divided by, let's say 5, so 5 is not actually a factor of 24, but if you divide 24 by 5, then you can multiply by 4, I think. So 5 multiplied by 4 is 20. You cannot multiply by 5 because if you multiply 5 by 5, then you get 25. 25 is bigger than 24. You can only multiply up to a number that gives number that is smaller than 24. So in this case, 4 is the quotient. So it doesn't have to be a number. It will not always be a number that gives exactly 24. 24 in fact can be divided by any number which is not necessarily its factors. So in this case, if you minus 20 from 24, you end up with 4. In this case, we can rewrite 24 this way. 24 is equal to 5 times 4. So 5 is the factor, 4 is its quotient, and then you add 4. So in this case, that 4 is this little 4 here, and this is called remainder. And just going back to integers, there are even integers and there are odd integers. So even integers go like this: -2, -4, 0, 2, 4, 6. So these are even numbers, which are still integers. So these are called even integers. And there are odd integers. And odd integers, it's obvious. It's -1, 1, not including 0. 0 is an even integer. -1, 1, and 3, 5, 7, 9, and it's got negative counterparts as well, -3, -5. So these are odd integers, and these are even integers. Obviously, the positive part can be called positive odd integers. Even integers, and these are positive odd integers. These negative parts are called negative even integers and negative odd integers here. Now I'm going to talk about what's called prime factorization. Prime factorization. So that's a very important skill in GRE maths. So Factorization, we need to investigate the term factorization first. Um, if you have number 60, 60 can be factorized as 3 times by 20. So rewriting a number in terms of the factors is called, that process is called factorization. Um, well, 60 can be written as 4 times by 15. So 4 is a factor, 15 is a factor of 60, so that's also factorization of 60. However, what is a prime factorization? Prime factorization is when you factorize a number just in terms of prime numbers. Prime numbers are numbers that can be divided by 1 or by itself. So numbers that are prime numbers are 2, 3, 5, 7, 11, 13, 17, 19, and like 23. So if you think about all these numbers, so could 11 be divided by any other number apart from 1 and 11 itself? The answer is no. The same goes for all these numbers. 23 can only be divided by 1 or 23. So these are all prime numbers. So how do we do prime factorization of 60? It goes like this. 60 is, well, if you divide 60 by, we can divide 60 by 2. So if you do that, that's equal to 2 times 30. Now, what can 30 be divided by? 30 can be divided by 3. 3 is the next prime number. Actually, it can be divided by 2 again. So 30 is 2 times by 15. And well, these two are prime numbers, so you don't have to factorize it any further. What can 15 be divided by? 15 can be divided by, well, cannot be divided by 2 exactly. So can be, the next prime number is 3. So 2 times 2 times, and 15 is 3 times by 5. And 5 is also a prime number. So 60 is prime factorized into 2 times 2 times 3 times by 5. That's how you do prime factorization. And in GRE maths, you will rarely encounter a prime number that is above 23. So pretty much these are the only prime numbers that you need to be aware of. So 2, 3, 5, 7, 11, 13, 17, 19, 23. There's a method called branch method for prime factorization. It goes like this. This you may find it easier than the method that I showed you here. 60 can be divided by 2 and 30 and keep dividing 30. So 2 and 15 becomes a 3 and times 5. So if you just collect all these prime numbers at the end, 2, 2, 3, 5, then you get 60. So 60 is 2 times 2 times 3 times 5, and that's indeed true. So you can prime factorize anything simply by dividing a number by prime numbers until you end up with just prime numbers. Okay. Another term that you often encounter in the maths exam is the word consecutive. Consecutive. So the term consecutive means in order. That's what it means. So if you have consecutive integers, so let's say there's a question asking for 3 consecutive integers. Um, they are simply just integers that increases by 1. So 5, 6, and 7. So these are 3 consecutive integers. If a question asks for 3 consecutive odd integers, then it can go like this: 5, 7, and 9. So these are 3 consecutive odd integers, and consecutive even integers can be like 4, 6, and 8. Okay, so that's what it means by consecutive. Um, Consecutive negative even integers can be negative, so therefore it could be -6, -4, and -2, and they are always in an increasing order. So in this case, this is known as negative consecutive even integers.